Unit 10 now. So 19, solve the following equations. So we're trying to solve for x. We're solving these exponential equations. All right, so we're trying to get x by itself. Right now we see that the x is in the exponent spot, so we want to get rid of the base first. But how can I get rid of a base of 3? What would I have to do? Log what? Log base 3, right? You're going to take log base 3 of both sides, remember, like this. And doing that is going to cancel this base of 3. So log base 3 of a base of 3, that cancels out. And so that brings down the 2x plus 1 into just like a normal number spot. It's not an exponent anymore. So it's just 2x plus 1 equals, what's on the right side then? Log base 3 of 81, that's right. Okay? And so you're not going to be able to solve this unless you can tell what log base 3 of 81 is. It's 4, right? Because 3 raised to the 4th power gives you 81. So log base 3 of 81 is 4. So now I have 2x plus 1 equals 4, and just solve from here. So how will I solve this? Minus 1. Right, 2x equals 3, and then divide by, hang on a second. 2x equals 3, divide by 2, and so what's your answer? X equals 3 over 2, very good. Now let's go ahead and do B because it's the same type of problem. So slightly different though. On B, you can notice that the bases are not the same, right? Yeah.
How do you get log base 3 of 81?
Equals 4. Because so what a logarithm says is, this is the base, right? 3 is the base, okay? So if 3 is the base, what exponent on the 3 will make it into 81? So yeah, 3 raised to the 4th power equals 81. That's what a logarithm tells you. Okay, so on B though, what we want to do on B is make the bases into the same number, right? So the 4, obviously we're not going to change that. Can I rewrite 64 as a power of 4?
Yes.
How? 4 to the third, right? 4 to the third is the same thing as 64. So I'm going to rewrite this equation like this. 4 raised to the x plus 1. Make sure you actually show this in the exponent spot. Equals 4 to the third, because that's 64, right? 4 to the third raised to the x minus 3. So notice what's in the exponent spot on the 4 to the third, right? We got a 3 up here and the x minus 3 up there. And so when you have two exponents next to each other like that, what can you do with them? Yeah, you multiply them. But the careful thing here, a lot of people mess up on the distribution in a lot of things. Right here with the 3, you got to multiply this 3 to both these exponents. So you're going to have 4 raised to the x plus 1 equals 4 raised to the 3x minus 9. That's right. Now that both of the bases are the same, what do you think you can do with those bases since they're the same on both sides of the equal sign? Yeah, you can just cancel them out. You don't need to worry about those. And so what is left?
X plus 1
Right, x plus 1 equals 3x minus 9. And how would I solve the rest of this problem then?
minus 1.
Minus 1? So what if we wanted to keep it positive because I don't like doing negatives? Add 9, right? So that gives you x plus 10 equals 3x, and then subtract x. Right?
X equals 5.
Yeah. X equals 5, that's right. Nice.